Hello, hello, and welcome. So today we are going over 2.6, sum and difference of cubes. So the goal is for today, by the end of the videos, you can say, I can apply the sum or difference of cubes formula to factor polynomials. Alright, so let's talk about what perfect squares and cubes are. Right, so a rational number that can be multiplied by itself once, right, is a perfect square. So, for example, 2 times 2 is 4. So 4 is a perfect square where you have a number multiplied with itself once, right? So 4 is a perfect square. So 1 is also a perfect square because 1 times 1, right? 2 times 2, which is 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 6 times 6. 7 times 7, oops. Perfect square of 8 would be 64. Right. 8, 9. Now I'm missing 81. 9 times 9. 10 times 10. 11 times 11. 12 times 12. And we'll do 13 times 13, which is 169. Okay, if you're going to remember any numbers, perfect squares 1 through 13 are the biggest ones to remember. Those come up the most often. Anything past 13 is not necessarily the most useful thing ever. I wouldn't worry about it too much, but at least know 1 through 13. Okay, perfect cubes is a rational number that can be multiplied by itself twice. Okay, so 1 times 1 times 1 is 1. So you notice that 1 is both a perfect square and perfect cube. Right? And then we have 2 times 2 times 2, which is 8. So 8 is considered a perfect cube of 2. Right? The perfect cube of 3 is 27. 3 times 3 times 3. 4 times 4 times 4 is 64. 5 cubed is 125. And 6 cubed doesn't come up as often, but 216. 6 times 6 times 6. Okay. Alright, so not too bad. If you remember any of the perfect cubes, I highly recommend 1 through 5. 6 is one of those, very rarely will it show up, but, it's occasional, it's possible. Okay? Alright, a little bit more vocab, so let's talk about sum. What does a sum mean? It's essentially where you have numbers that have been added. Alright, what does difference mean? It's when you have numbers subtracted. Alright, so factoring the sum or difference of cubes is simply a special case of factoring when there are only two terms. Two terms. Okay, if you have more than two terms, this is maybe not something you're looking for, right? This only occurs when you have two terms. Dos. Okay, alright, so always try to make sure that you are looking for a GCF. First step, always and forever look for a GCF. Okay? If you don't have a GCF, or if you do, factor it out, right? The next thing you then look for are all of your terms perfect cubes, right? This is assuming that there are only two terms, right? If there are more than two terms, this isn't going to work. Okay? And then you should ask yourself, okay, if all of your terms are perfect cubes, meaning that, the numbers are 27, 125, 64, so on and so forth, right? If you have perfect cubes, then is it a sum or difference of cubes? Meaning, is there addition or is there subtraction between your perfect cubes? Okay, if it's addition, we call it the sum of cubes. If it's subtraction, we call it the difference of cubes. Alright, so from there we need to find out what is A and what is B. Right? Because when we do this, we're like, okay, is A a perfect cube or is this first term a perfect cube? Yes. Of what? Right? We want to figure out what that what is. Clearly my grammar is on point today. Alright, so let's just go right into it. Let's go through some examples. Alright, so example 1, factor the following expressions completely, if possible. I'm looking through this and I'd say, okay, 1 plus x cubed. First thing I'm looking for, is there a GCF? Nope. So there's no GCF. And then I'd say, okay, are these perfect cubes? And I'd say, all right, so 1, it is a perfect cube. 1 times 1 times 1. Now, is x cubed a perfect cube? Yeah, literally, remember, if I have 5 squared, that's the same thing as 25. X cubed is the same thing as x times x times x. There are 3 of them multiplied together. That is a perfect cube. Okay? Remember definitions of exponents from that one. So we both have perfect cubes. So from there, we need to identify what we have being cubed. Apologies for that break. So we have a equals what? And then b equals what? So what's being cubed here? What number is being multiplied 3 times? It's 1. Right? And then back here we have x cubed. So what's being multiplied 3 times? X. Right? Because remember, x cubed is the same thing as x times x times x. What was the same thing we literally just multiplied 3 times? It was x. So that was A, that was B. Now from there, all we do, you plug it into the formula. So the formula for a sum of cubes, it's gonna be this one, and I'm just gonna bring it down. Where we have A plus B, A squared minus AB plus B squared. And now all you do is wherever you see an A, you plug in 1. Wherever you see a B, you plug in an x. Alright, so we have 1 plus x, 1 squared minus 1 times x, plus x squared. And then you just simplify, right? You make it look a little pretty. Now, is 1 plus x looks kind of awkward, right? We're used to seeing it as x plus 1, so I'm just going to flip the order on that one, going to change it up a little, right? And we can do that, because 2 plus 3, is that the same thing as 3 plus 2? It is. Right? Likewise, what's 1 squared? 1. Right? What's 1 times x? X. Right? And then x squared is not going to change. Now, again, I'm going to change this into standard form, where it's x squared minus x plus 1. Alright? And that's it. Now it looks a little more normal. We factored it by the formula. That's all you have to do. So plug it in, simplify it down, make it look pretty if you need. Now we have y cubed minus 27. Let's go through that same process. I'd say, okay, is there a GCF? Nope, there is not, right? There's no number in front of our y cubed other than 1. There's no variable here, so we're good to go. Alright, do we have perfect cubes? Yes. Right, because y is being cubed, right? So what's being cubed? Y. Alright, on our next one, remember 27 is on that list of perfect cubes. That is 3 cubed. 3 times 3 times 3, so b is 3. That's what's being cubed. Alright, and then I say, okay, is this a sum or a difference? Difference is subtraction. Alright, so if difference is subtraction, then I just pull down that difference of cubes formula. So I'm just going to copy it down here. So it's a minus b, a squared plus ab plus b squared. Everywhere you see an a, you put in a y. Everywhere you see a b, you stick 3 in there. And I just changed the format on this one. It's y times 3, which is 3y. Oh, whoops, sorry, b squared. That would be 9. Alright, and here we don't have to change anything up. It's already in a good format. So we're good to go. Alright, so I'm just going to, if you want any more examples, go ahead and check out next video.